In 1969, Buzz Aldrin saw flashes of light with his eyes closed while trying to sleep on the moon. Neil Armstrong saw them too. So did every Apollo astronaut who left Earth's orbit. These weren't hallucinations. They were cosmic rays literally shooting through their eyeballs, triggering false signals in their retinas like microscopic bullets made of light. Decades later, 80% of these astronauts developed cataracts. This is just the beginning of space radiation's assault on the human body. Want to go to Mars? Your DNA is about to become target practice for the universe's most powerful particle accelerator. This is the terrifying reality of space radiation that could end our dreams of becoming an interplanetary species. Right now, you're being hit by 15 million cosmic rays every hour. Don't panic. Earth's magnetic field and atmosphere block 99.9% of them. But step outside that protective bubble, and you're naked before the universe's nuclear fury. Space radiation isn't like an X-ray at the dentist. It's a constant bombardment of particles moving at near light speed, each one capable of shattering your DNA like a wrecking ball through a house of cards. There are three killers out there. First, cosmic rays, atomic nuclei stripped of electrons, accelerated by supernovas and black holes to 99.99% the speed of light. When one hits your body, it doesn't just damage one cell. It creates a cascade of secondary particles, like a cosmic shotgun blast through your tissues. One particle becomes dozens, each carving its own path of destruction. Second, solar particle events. When our sun throws a tantrum and hurls billions of tons of charged particles into space at millions of miles per hour. In August 1972, between Apollo 16 and 17, a solar storm hit that would have killed any astronaut outside Earth's magnetic field within hours. NASA got lucky. Pure, dumb luck. Third, the Van Allen belts, Earth's own radiation prison, where charged particles spiral around magnetic field lines at near light speed. Flying through them is like running through a nuclear reactor. The Apollo astronauts did it in 90 minutes, absorbing radiation equivalent to hundreds of chest X-rays. They survived because they flew through quickly. Stay longer, and you cook. Here's what a single cosmic ray does to your body. It punches through your skin like it isn't there, tears through muscle and bone, and if you're unlucky, hits a DNA strand. The particle doesn't just break the DNA, it explodes it. The energy transfer creates free radicals that continue damaging surrounding cells for hours. Your body tries to repair the damage, but sometimes it repairs it wrong. That mistake? That's cancer waiting to happen. But cosmic rays do something worse. They target your brain. Unlike other radiation, cosmic rays create secondary particles that preferentially damage the hippocampus, your memory center. Mice exposed to cosmic ray doses equivalent to a Mars mission showed 30% cognitive decline. They became confused, anxious, couldn't learn new tasks. Now imagine that happening to astronauts trying to land on Mars after 6 months of exposure. Your cardiovascular system gets hammered too. Radiation damages the endothelial cells lining your blood vessels. They become inflamed, stiff, prone to plaque buildup. Soviet cosmonauts who spent months on Mir showed arterial aging equivalent to 10-15 years in just 6 months. Their hearts literally aged decades in space. The reproductive system? Devastated. Male astronauts show reduced sperm count and motility that can last years. Female astronauts face higher miscarriage risk and potential infertility. NASA quietly recommends astronauts bank sperm or eggs before long missions. The radiation dose from a Mars mission could sterilize you permanently. A trip to Mars takes 6 to 9 months each way. During that journey, you'll absorb 100 times more radiation than on Earth. That's equivalent to getting a whole-body CT scan every 6 days for 2 years. NASA estimates a 3% increased lifetime cancer risk for a Mars mission. That's the optimistic estimate. But here's the nightmare scenario. A solar storm during the mission. On Earth, we get 30 minutes warning before particles arrive. In deep space, you might get 5. Where do you hide in a spacecraft the size of a school bus? The Curiosity rover detected a solar event in 2013 that would have delivered a potentially lethal dose to any astronaut on Mars's surface. Mars itself offers no protection. Its atmosphere is 1% of Earth's, useless against radiation. No magnetic field means cosmic rays hit the surface full force. The soil becomes radioactive. Dust storms carry radioactive particles. Living on Mars means living in a radiation pressure cooker. Growing food? The plants absorb radioactive elements from the soil. Your lettuce becomes low-level nuclear waste. The psychological impact is crushing. Astronauts know every day in space increases cancer risk. Every solar flare warning triggers anxiety. Some astronauts report becoming obsessed with radiation exposure, checking dosimeters constantly, calculating cancer odds. It's like playing Russian roulette, where the bullet is invisible and takes 20 years to kill you. NASA knew about radiation dangers during Apollo, but downplayed them. Publicly, they said astronauts received doses equivalent to a few chest X-rays. Privately, they were terrified. Each astronaut wore dosimeters, but the readings were classified for years. Why? Because the truth would have ended the program. Apollo astronauts absorbed 200 times normal background radiation. They reported seeing flashes every 3 minutes, cosmic rays hitting their retinas. Some saw shooting stars inside the spacecraft. Charlie Duke said it was like fireflies in my eyeballs. These weren't beautiful phenomena. They were subatomic bullets causing permanent damage. The long-term effects are telling. Apollo astronauts die from cardiovascular disease at 5 times the rate of other astronauts. Of the 24 people who've traveled beyond Earth's magnetic field, 7 have died from heart disease or cancer, way above statistical average. Alan Shepard, Pete Conrad, Jim Irwin, all dead from cancer or heart disease, potentially linked to radiation exposure. NASA's own documents, declassified in the 1990s, reveal they accepted a 3% chance of fatal cancer per astronaut as acceptable risk. They never told the astronauts this number. The astronauts were volunteering to die, statistically speaking, and didn't know it. Every solution we've tried has problems. Lead shielding? Too heavy and cosmic rays create secondary radiation when hitting it, making things worse. Water shielding? You'd need walls 3 feet thick. A Mars spacecraft would weigh 500 tons just in water. Magnetic shielding? The magnets required would weigh more than the spacecraft and create their own problems. Pharmaceutical radioprotectors exist, but have severe side effects. Amifostine reduces radiation damage, but causes violent nausea and blood pressure crashes. Perfect for astronauts trying to operate complex equipment. Other drugs protect specific organs, but leave others vulnerable. You can't drug your way out of physics. Underground habitats on Mars? You'd need 10 feet of regolith overhead for protection. Digging that requires massive equipment we can't transport. Surface habitats with regolith piled on top? The weight would crush most designs. 3D printing habitats from Martian soil? The printers would break down from radiation damage before finishing. The ISS orbits within Earth's magnetosphere, protected from the worst radiation. Even there, astronauts hit lifetime radiation limits. Peggy Whitson, the American record holder for time in space, can never fly again. She's maxed out her lifetime dose. She's a walking radiation experiment, monitored for life. Here's what nobody talks about: transgenerational effects. Radiation doesn't just damage you, it damages your genetic legacy. Studies on atomic bomb survivors show increased cancer rates in their children and grandchildren. The radiation you absorb in space could affect your great-grandchildren. Space radiation causes chromosomal aberrations that persist for years. Blood samples from astronauts show broken and rearranged chromosomes that never fully heal. These aberrations are biomarkers for future cancer. Every astronaut becomes a ticking genetic time bomb, waiting to see if damaged DNA turns malignant. The immune system crashes in space, partly due to radiation. T-cell function drops 50%. Dormant viruses reactivate. Astronauts on ISS frequently develop shingles, herpes outbreaks, Epstein-Barr reactivation. Their bodies can't fight off infections that Earth-bound immune systems handle easily. On Mars, a simple cold could be fatal. Brain damage accumulates silently. Astronauts show white matter changes similar to traumatic brain injury. Processing speed decreases. Depression and anxiety increase. Some develop a condition called space brain, persistent fog, memory problems, personality changes. It doesn't improve after returning to Earth. Space agencies face an ethical dilemma. Tell astronauts the true risks, and nobody volunteers. Hide the risks, and you're sending people to their deaths uninformed. Current consent forms use language like increased cancer risk, without explaining that increased might mean guaranteed for Mars missions. Insurance companies won't cover astronauts for long-term health effects. NASA's lifetime healthcare commitment to astronauts is carefully worded to exclude many radiation-related illnesses. Private space companies? Even less protection. SpaceX's Mars Colonist Agreement includes accepting death as a likely outcome. Should we let people volunteer for suicide missions if they're fully informed?